Previously, we've looked at collecting data. So let's imagine we've got a load of data. What we're going to do with it? Well, one thing you can do is you can display it to kind of, give a better, bit of a better feel than just looking at a load of numbers or words, and gain insight. And after that, you can maybe do some investigation of the data and, do some calculations. But first of all going to focus on displaying the data. And the first thing we're going to look at is types of data. So we've observed or measured something, and then what we've observed or measured tends to be called a variable. So it could be, the color of butterflies that you're looking at in an investigation, or what shoppers think about a certain product. Well, here are some other ones. And what I want you to do is pause the video and have a think how you might classify into some different categories these types of data. Well, I'm sure there's possibly lots of ways of doing it, but two that we tend to go with in maths are we say that variables are qualitative or quantitative. And other words for these are categorical and numerical. So one way to remember, so you don't get mixed up between qualitative and quantitative, is to remember that quantitative means is related to quantity. So that's how you can basically remember it's to do with numbers. And then qualitative, maybe to do with the quality. That feels a bit of a looser definition. So go with the quantitative as quantity, and then qualitative is the other one, the wordy one. And then also, quantitative data can be further split into either being discrete, where we can list all the possibilities, or continuous, where we can't list all the possibilities. So before I say any more, I'm going to challenge you. Can you pause the video and see if you can classify the variables above? Okay, my feeling is that, so I'm going to do a little key, I think. Quantitative, and then qualitative in green. So I'd say that this is qualitative, and this one and the others seem to be numerical. So they're going to be quantitative. Here, 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 here. Okay, however, this one, although it's got numbers in, it's a bit of a strange one really, because you wouldn't ever calculate the mean number of a squad really, although maybe you would. But sometimes things like this also get thrown in as qualitative. Okay, maybe you're frowning at me right now and thinking, no, it's numbers. But it's just because it's not really, you can't really, like with the marks, you can kind of do some statistics with it, with the coin throws, with the heights, but it doesn't really make any have any meaning to do it with the squad numbers. So it's just a list of different people you've seen, really, I suppose. I can kind of see how this could be put as either, but I'm going to leave it as qualitative for now. Okay, and then within qualitative, we've got discrete. Actually, I'm not going to add too many colors. I think that'll make it confusing. So discrete is when, remember, it can just take some values. Okay, I can list all the possible values, whereas continuous I can't. So I think going through this will make this clear. Dice throws is discrete because I can't get 2.5 dice throws, and I can list them all. It's discrete. Heights, however, continuous because I could get a height in between any of these values. I know I've rounded them to three significant figures, but I could get a height that's any value. It's called a continuous variable. Number of coin throws until a head is obtained, that is going to be discrete as well. I can't do it in half a coin throw. Marks awarded by judges. Well, here I'm not allowed to award 4.95, so actually technically this is discrete as well. So note the difference. With heights, it's because it can take any value I write down, I could find a value in between. Even though I'd then round it up, Whereas when you award marks at a skating event, you don't award, there's only a certain number of values you can award. And then judgment of level of pain, okay, that's going to be discrete as well. Note also that these essentially are the same thing, but here I've done it as qualitative data, and here I've done it as quantitative. I've actually scored none as being 0, mild as being 1, moderate as being 2, and although I think I've made a mistake somewhere because I've introduced an extra one, so sorry, that should be a 3. No, what have I done here? I was only just trying to show that we could write a number down for the mild, acute, and moderate. And so you can basically, sometimes with some data, you can kind of go between quantitative and qualitative. Okay, good. Here's a little summary of this, and it's important to know. Now, we're not going to be really looking at qualitative in this stats course at all. In fact, I mean, you need to know what it is, but it's less easy to do data on it, to do sort of investigations into qualitative data. You've just got a list of things. It's not quite so, there's not quite so much you can do. We're going to be therefore focusing on quantitative, and we are going to be looking at both discrete variables and continuous variables. We'll find out more about those. You've probably spent actually time looking at, maybe you haven't, looking at sort of the number of coin throws and so on. It doesn't really come up in GCSE maths now I think about it, the distinction between these two. So anyway, we're going to be looking at both of these in more detail. We've looked at types of data. Now we're going to look at how you might display some of this quantitative data. So below, this is a list of raw scores when I've been rolling a die. Raw, and we call this raw data. Note the set notation, sometimes used to indicate that it's like all the possible values in a set. Now, my little task for you is how could you represent this in a frequency table? Try this now. Okay, well for this you need to sort of count up all the 1s or the 2s and all the 3s and so on, write down the possible scores you can have, and then write down the frequency that goes alongside it. For example, there are 1, 2, 3 1s. Sometimes you get you write the total at the bottom, not always, that's optional, but the main thing is these are equivalents. They're just slightly different ways of writing this raw data. Okay, if we move on, then sometimes we also, and I'll talk more about this, but we use a grouped frequency table instead. Basically, it's because now there's so many values that you can't really represent it as a frequency table because it'd just be too big. So we put them into groups, and then we can still use this. We still have a lot about the information. One thing to note though is that we no longer have raw data, not raw data, because we don't know what the values are. We knew exactly what they were here, but now we just know that there are 2 values in between 0 and 10. So my task for you is just, do you understand that? Can you write down the 6 values, or 6 possible values, I should say, that could go into the first 2 groups? Well, we could have 1 and we could have 2, or we could have 1 and we could have 9 in the first group, and then we could maybe have 10, I don't know, 12, maybe these are quite evenly spread, 14, and maybe another 14. So these are possible values that could fit in there, but actually there's lots of possible values, and that's kind of the point, because we've lost accuracy. We don't know exactly what's going on anymore, and we have to make estimates. That's enough on that's enough on kind of the idea of group frequency tables for now. But I am going to talk about a little bit more about when they're used. So I've talked about it when they're widely spread. So here's a little bit more on that. If I had some values like this is a lot of raw data. Wouldn't be much good as a frequency table. I just get a lot of numbers all with frequency 1. So if I group it up, maybe between, like, for every 10,000, then I can get a group frequency table, and this starts to give me a bit of an idea about the spread of the data. We can see that most crowds are between 10,000 and 30,000, a lot between 10,000 and 20,000 in particular. Just to note, this is actually discrete data, so you can see there's no overlap, but because I'm talking about spectators at football matches, I can't have 9,999.5, for example, so I represent it like this. Okay, the question is, how do I decide to group it? I've chosen to do 10,000 here, but why not do something else? What if I did every 1,000? Well, this is what happens. You can see it sort of becomes a bit useless because now, although I've got more information, I've sort of lost the kind of feel for the data sets. I can kind of see there's a load going on here, but there's just too many numbers to look at to be able to make simple statements. What if I did 0 to 20,000? Well, then it's all condensed, and actually, again, I don't, this is not that useful. I can see a lot between 0 and 20,000, but I don't really get a good feel. One thing that gives me a little bit more would be if I did every 5,000. So now, actually, this really pinpoints. We see there are loads between 15,000 and 19,999. So I guess the idea is to get maybe 5 to 10 groups, and then you get a bit of a feel for the distribution without losing too much of your data. That's just something to take on board if you ever construct a group frequency table yourself. Okay, moving on. If we look at continuous data, this is when we tend to use inequalities. You don't tend to use inequalities for discrete because you can't get these 0.5 values. But for continuous, you do. Again, we make sure there's no overlap between groups. So we use these inequality symbols like this. We've got some heights here. I didn't say that, but that's what makes it continuous. Another way of representing it is like this. So just be aware. Okay, that means the same as this essentially. So just slightly shorthand, but so lots of different ways of representing data. That's what we're getting at today. Okay. We've looked at raw data either written as just as a list or as a frequency table. We've also looked at grouped frequency tables where you lose some of the information. You need to think carefully about your grouping. One way of representing data that's kind of mingling, I suppose, in between these is something known as a stem and leaf diagram. Now, you may have encountered these before, or they may be new to you. It depends, because they're on some GCSE syllabuses and not on some other ones, or perhaps in other countries that you may have studied them as well. I don't know. So I'm gonna assume you've not studied them, but I'm gonna go for a fair pace because they are essentially a GCSE idea. And this is an example of a stem and leaf diagram. So when you first look at it, it might be a bit confusing. Why are there like all these 0, 1s, 2, 3s, 4, 5s, and then all these numbers here? But the key explains it. So essentially, if you have 2 and then a line and then a 5, it means 25. So this number here with the 9, well, it goes with the 3, and actually it refers to 39, whereas this one refers to 0, 6. So if I just ask you a few questions, what will this number be? Okay, that number is going to be 18. And what about this one? That one's going to be 45. What if I wanted to, I don't know, put in 57? Then I'd line a 7 up right here, just after the 0. Note, these are ordered. They won't always be ordered. It might be, you do get this. So this is an example of an ordered stem and leaf diagram. I'm just going to call it ordered, but you could get the numbers in a different line as well. Okay, now we've said that, let's have a go at looking at a real life example. Construct a stem and leaf diagram. Actually, before we do that, I didn't really say this, did I? But why is it called a stem and leaf? Because this is the stem. It's kind of like the main bit that decides the tens units. In this case, it's the tens units. And then the leaf is this. It looks, a little bit like a flag, actually, no, but a little bit like a stem and a leaf, okay? All right, back to this one. So, this could be something that maybe a council investigated. They're worried about the water supplies, real life kind of example. How could we construct a stem leaf diagram that might give us a bit more indication? Because, sorry, I keep forgetting this, but actually, this is raw data. We've got all the data. It's just rather than writing it as a long list or as a frequency table, we're kind of, we couldn't do it as a frequency table very easily because all the numbers are different, but we don't lose accuracy that we would do if you made it a grouped frequency table. And it tells us a bit about the spread and what's going on. So it's like an in-between thing, exact data, but in the case where you have lots of different values, that's when stem and leaf diagrams can be really useful. Okay, back to this one. Right, we'll do it now. Okay, if you're feeling confident, if you think like, yeah, I get that there, I want you to just give this your best shot. Pause the video and have a go. Okay, so if I'm doing this one, I'm going to get my stem in, as you can see, and then I'm going to draw a line across. That's kind of optional actually, but let's do that. And then in this case, it's not going to be tens, it's going to be 1 point something or 0 point something, but I've got some that are 0 point something, I've got some that are 1 point something, 2 point something, and the highest one I think is 3 point something. Now I'm going to go straight to making it ordered. You could just write them down. Actually, no, do you know what? As an example, I'm just going to show you how you might make it unordered to start with, because then you don't need to worry too much. You can just get it drawn. So I've got a 1, and then I've got a 4. Okay, that happens to be in order, but okay. I've got a 1.1. Oh, I missed a 0.8, sorry. I've done all the 0 point somethings now. I've got a 1.3. I've got a 1.2. 5. I'm trying to line them up here so that the 2 goes with the 8 and so on. I've got a 9. I've got a 9. I've just realized I missed a 6. This is what's good if you're doing an unordered one. It doesn't matter if you miss one. Then I've got a 2.6. I've got a 2.0. I've got a 2.2. And I've got a 3. And I just need to make my key. So I might say like 1 slash, it's not slash, but a line means 1.8. So this would be unordered because they're not, it goes 602. So if I wanted to make it ordered, I could quickly do it from the unordered one. You might argue that I should have just done this in the first place. Okay, and now I just need to write it in order. 1, 4, 6, 8. 1, 2, 3, 5, 7, 9, 9, 0, 2, 6, 3. Don't forget the key. And there we have it. We have constructed a stem and leaf diagram, an unordered one and an ordered one. Just make sure you can deal with both. Typically, like ordered ones are more useful, of course, because we're going to be looking at things like calculating the median using a stem and leaf diagram. Finally, I'm just going to mention visualizing data. So the frequency tables don't really give you a visualization of what's happening, other than like giving you the numbers, and you can kind of see what's going on. Stem and leaf actually is then in between. It gives you a graphical picture, sort of, like a little kind of bar chart going sideways sort of thing, but with the actual values there. And other types include like the following. So these are ones you should be familiar with. You will have probably encountered them a long time ago, but be just familiar with pictograms. Here you might have a key. It might be that one turtle equals, I don't know, four pets. Like one picture of the turtle represents 2 actual turtles or something like that. Got line graphs that they can be useful in different situations where you're plotting them and joining them up. Pie charts, Okay, don't forget about those. Here are a few that you may not be familiar with. You will have seen bar charts before. Typically, these are used for qualitative data. Okay, like your favorite film or your favorite soap opera here, or your eye color or something. Um, Whereas more so with quantitative data, we draw a vertical line graph, very similar, but we just don't give it a width. They're essentially the same thing because you're meant to have gaps in between your bars here because it's discrete. Well, it's not discrete because it's qualitative, and you have gaps here because it's discrete data. The same goes for these dot plots. Actually, these two are exactly the same data sets, just slightly different ways of representing them. Okay, moving on. There's box and whisker plots that I will assume you've seen before, but we will be looking at those. We've just talked about stem and leaf. So stem and leaf is kind of this interesting link between frequency tables and a visualization. Histograms, they're used for continuous data. Okay, so that's when you do start, you don't leave any gaps between your bars. And then two more, or actually three more, scatter graphs. Actually, these are for bivariate data, when you've got two things linked together, whereas the other ones are just for single variable. We'll be looking at them in more detail. Cumulative frequency is when you have a running total. I know that diagram is quite small. I made this one quite big, so there's something called a radar chart. You should just, looking at it now and getting a bit of familiarity is good. If you ever played Pokemon, then this might have come in useful. Knowing the Pokemon base stats for some of the Pokemon you could get right at the start of the game. We've got the fact that Pikachu is the fastest, and we can compare them all really quickly using this nice radar charts. Okay, that is it for this lesson. We've covered quite a lot. It's just like quite a lot of information that you need to know that I've spoken about. I'd say the key things, and make sure you know the definitions: quantitative, qualitative. Make sure you understand the difference between discrete and continuous. Actually, within statistics, they are dealt with. There's overlap between them, but they're dealt with differently, and you'll see why later on. We've looked at frequency tables and group frequency tables and like about what a good grouping is. And then we moved on to stem and leaf, understood what that is, had to go at drawing one, talked about ordered and unordered stem and leaf, and then finally just looked at this visualization. So just make sure that you're happy with all of this, make some brief notes, and then try some questions. Good job.